We now discuss the solution of a problem from the section Real Analysis. The question is based on the Fundamental Theorem of Calculus. This question has appeared in the CSIR National Eligibility Test held on 16th February 2022 and it is from the part C of the question paper. The given question is, let f be a function from the closed and bounded interval 0 to 1 to R, the set of real numbers, and it is continuous such that integral 0 to t f of x dx is equal to integral t to 1 f of x dx for every t belongs to 0 to 1. Then, which of the following are necessarily true? Which of the following are necessarily true? We are given four options. Option 1, f is differentiable on the open interval 0 to 1, and option 2, f is monotonic on the closed and bounded interval 0 to 1. Option 3, integral 0 to 1 f of x dx is equal to 1. Option 4, f of x is greater than 0 for all rationals x belongs to the closed and bounded interval 0 to 1. We are given a function f defined from 0, the closed and bounded interval 0, 1 to R, the set of real numbers. And it is given that f is a continuous function and it satisfies the integral 0 to t f of x dx is equal to integral t to 1 f of x dx for every t belongs to the closed and bounded interval 0 to 1. Then, which of the following are necessarily true? From among these four options, which of them are true? We have to prove what are necessarily true from among these four options. Okay. We now discuss the solution of the problem in detail. We have the function f from the closed and bounded interval 0 to 1 to R, and it satisfies integral 0 to t f of x dx is equal to integral t to 1 f of x dx for all t belongs to the closed and bounded interval 0 to 1. This implies this one, the first one, integral 0 to t f of x dx, as it is we have written, this is equal to, and instead of t to 1 we have written 1 to t, integral 1 to t f x dx, and to compensate that one we have a minus sign here. Agreed. Let phi of t is equal to integral 0 to t f of x dx, and that is equal to minus integral 1 to t f of x dx. And remember that f is a continuous function. F is a continuous function. Now, since f is continuous on the closed and bounded interval 0 to 1, phi is also continuous, and phi of t is differentiable, and phi prime t is equal to f of t, and it is equal to minus f of t for all t belongs to 0 to 1. Here we are applying the fundamental theorem of calculus. Agreed. Now we got f of t is equal to minus f of t for all t belongs to the closed and bounded interval 0 to 1. This will imply 2 times ft is equal to 0. This will imply f of t is equal to 0 for all t belongs to the closed and bounded interval 0 to 1. So, what is this? This is a zero function. F is a zero function on 0 to on the closed and bound interval 0 to 1. So now integral 0 to 1 f of x dx is equal to integral 0 to 1 f of x is a zero function. For every x, f of x is 0. So integral 0 to 1 0 times 0 dx is 0. Therefore, the option 3, integral 0 to 1 f of x dx is equal to 1 is not true. Option 3 is this one, which says the integral 0 to 1 f of x dx is 1, but it is 0 because f is the 0 function. Therefore, option 3 is not true. Now, the option 4 says f of x is greater than 0, positive. For all rationals, x belongs to 0 to 1. That means when x is a rational number in this interval 0 to 1, f of x is positive. That is the option 4. But this is not true. Why? Because f of x is 0 for all x belongs to the 0 to 1. Even for when x is rational also, f of x is 0. So therefore the option 4 is not true. We discuss options 1 and 2 in the next slide. We have seen f of t is equal to 0 for all t belongs to the closed and bound interval 0 to 1. That is, f is the 0 function on the interval 0 to 1. That is, f is a constant function on 0 to 1. When it is a constant function, then it is differentiable and it is monotonic. So, f is differentiable on the open interval 0 to 1 since every constant function is differentiable, and f is monotonic on the closed and bound interval 0 to 1 since every constant function is monotonic. Right. So these are the properties of constant function, and let's look at our option. Option 1 says f is differentiable on 0 to 1, which is true. Option 2 is f is monotonic on the closed and bound interval 0 to 1, which is also true. Therefore, the options 1 and 2 are true. So the answer for this question is option 1 and 2. They are true. And options 3 and 4 are not true. So that is the detailed discussion of the solution of the problem from the section real analysis. And the question is based on the fundamental theorem of calculus. And I am sure that you have understood the solution of this problem. And I wish you all the best. Thank you.